My name is Thomas Edwards with Fox Networks Engineering and Operations. This is all about higher level IP functionality. It's not enough just to move video. We actually have to register things and discover them and connect them together and make it all work. And that's what this session's about. Our first speaker tonight is John Myatt, CTO of Networking and Infrastructure at Imagine Communications. He is not only the document editor of the SMPTE 2110 core standards, a completely thankless and painful job, he also has 2 degrees from MIT, yet he decides to remain in broadcast engineering. He'll be speaking about systemization of SMPTE 2110 environments using AMWA IS04 and IS05 control protocols, and maybe even this full stack thing I keep hearing about. Please take it away, John.
Okay, well, thank you, Thomas, and thank you, everyone, for coming and enjoying this session, or at least enjoying a good, comfortable chair to sit in. As you mentioned, my name is John Myatt, and the talk is really about, in fact, a thing called the full stack. Now, the full stack idea came about really last June at the EBU NTS, if anybody goes to the EBU Network Technology Seminar. I think that's what that stands for. It's hosted graciously by the EBU, Mr. Hoffman and company. And we had, much like at this session, this last few days, a lot of talks about 2110 and PTP and this and that and all these little parts. And several of the EBU members, rightfully, stood up and objected and said, these are all great parts, but we need to build a system. And so I believe it was Mr. Edwards coined the term, the full stack, that we have to document the full stack of protocols and processes and behaviors that lead to a system. And so this work is the output of that discussion. And so your feedback is encouraged and needed and welcome. So this was a chart that the EBU put together as voice of the customer. The EBU, if you don't know who they are, they represent the public broadcasters throughout Europe with a pretty liberal definition of Europe because Canada is somehow part of Europe, as are some other countries that you wouldn't necessarily think of as European. So they pretty much, as I described, they say, okay, great, media transport, the little orange, green part at top, we've got standards for that. Timing and synchronization, okay, PTP and so forth, we've got mostly great standards for that, but everyone's still just the slightest bit of the edges of PTP sometimes people still are concerned about, although if you're still concerned, talk to Thomas Kernan and he'll tell you why not to worry. Discovery and connection, the AMWA's put together some great protocols for that are starting to gain some traction in the industry. But then you get down to the red part of the pyramid, you say, okay, configuration and monitoring and how do things get assigned addresses, all that. It's really not necessarily in such great shape, yet if you're going to build a system at scale, you'd really like that to happen without too much pain. And then we get down to the bottom of the part nobody ever wants to talk about, security. And we all know that there's a million ways to fail down there, and that's why we don't even like to talk about it. So all that said, what is the problem we're trying to solve? It can't be a SMPTE meeting if you don't say that at least once. So the problem we're trying to solve in the full stack is very simple. Customer buys a new piece of 2110 equipment. What all do they need to do to get it running in their facility? And is it reasonable? And I think we all say, well, right now, maybe it's not reasonable what they have to do. They have to know too much. And so could it be reasonable? Could we automate things? Could we define some boundaries of expectation or something to make it reasonable? So that led to the full stack. So what is a full stack for us? A full stack says, for some domain of use, what are the requirements on the devices and on the environment they live in so that a customer can take delivery of a new thing, attach it to the networks, plural, I guess, and have a straightforward workflow leading to using it. That sounds optimal, right? Does anybody think that that's a bad goal? Okay. So we just used a bunch of words that aren't defined well, right? What's a domain of use? What's a media node? What's an environment? What are standards? What are behaviors? What's a straightforward workflow? So domain of use, well, that's pretty easy, actually. Everyone kind of agreed on that one. It's, you know, it's systems like we build, right? The problem we have is 2110 and IS-04 and IS-05 and SMPTE 2059, they were all written to be really flexible. They were written to cover all kinds of use cases. But the full stack, we wanted to be more specific. So for our purpose in this document, because all good work comes to a document at the end, the domain of use is engineered facilities. So not, oh, I plugged two things together in my garage, but a designed, engineered facility with an engineered IP network that's producing, packaging, delivering, making television or radio content. Well, that's the domain we all work in mostly, except for the film people. That's a little different, but I'll count that. Built around these technologies. If you're building around some other set of technologies, this is not the document for you. So, you know, to turn that into work, we said, well, what's a scope? So this recommendation, it enumerates some standards, some specifications, and it defines some operational behaviors. And these behaviors kind of cross the standards because they say, you know, the device should do this, where it's really more broad than just the scope of, say, 2110 or 2059. It kind of encompasses more. And so the domain of use is, like we said, engineered fixed professional media infrastructures. That doesn't turn into an acronym no matter how you rearrange it. Okay, so that's scope. Now, what are these other things? What's a media node? Well, I had to come up with some word other than device, because device means a different thing to every person who hears it. So okay, well, let's call these things media nodes, because that's good as any. It exposes an IS-04 node API. So media nodes are things that speak and eat 2110. The environment has control networks and media networks that interact with these nodes. And within those networks, there's services like IS-04 and IS-05 and so forth. So one way to think about this document is it's the contract between the device that you buy from your favorite vendor and the environment that it lives in. So that device knows what it's getting into when it comes out of the shrink wrap at your plant. Now, the last piece is sort of interesting. What's a straightforward workflow? Well, it's hard to define that. But the idea is that you want it to be something that can be done by an operations staffer without a huge amount of engineering knowledge. So when you introduce a new device, you probably do want a human in the loop to at least say, hey, yes, I hooked that up, as opposed to somebody snuck in and plugged it in, right? Because, you know, security, right? And frankly, devices need names to make sense in your operation. You know, that box you bought from your vendor doesn't know that it's going to be camera 7 in your plant. It just, you know, you got to assign a name somewhere. That's a human operation. So we'd like to keep the human part of the workflow down to that simple stuff, assigning names and approving the device to be part of the running network. Otherwise, you know, don't ask too much work, because the whole point of this is to save some time and effort. So what's the network look like? What's the environment look like? Well, media nodes sometimes connect to a control network, but it's not required because you can do the control over the media network. Perfectly valid to do that. Media nodes do connect to at least one media network because, well, if you don't connect to a media network, you're not a media node and you aren't doing anything and you're out of scope. You'll notice that there's these network services like PTP is a network service that's available on those media networks. DHCP is a network service. IS-04 is a network service. So standards, we got lots of them. We use them all. So yes, 2110, 2059, IS-04 and 5. 802.1ab, that's not one everyone thinks about, but that's how the network knows what's connected to it. It's actually a really handy thing if devices implement that. And you know something? It's built into the Linux kernel. It's built into the Windows kernel. And if a device isn't already doing it, it's because you forgot to turn it on. It's not that hard. Link aggregation. If you're going to have multiple connections to the control network, we specify that you'll use link aggregation because, you know, the control network is becoming really important. And that single connection to it is actually a single point of failure for devices now. So that's fine. Standards, we all understand standards. The rest of this talks about behaviors, because that's what we also have to standardize here or to specify, is the behaviors. How does a device know its network information? How does it know if it's in a new system or an old system? How does it know the PTP domain? How does it find the registry? How does it know what multicast addresses to use? That's the hard part and the interesting part of the full stack. So let's drive through. In case you didn't hear the victory lap, the 2110 standards are basically done. So are the 2059 documents. In fact, both are now starting their cycle of one-year reviews, which will probably really be two-year reviews by the time they're done. We tend to understand the domain, the devices, the environment, the workflow. That all is pretty clear. These behaviors are the hard part. So the first behavior, it's interesting, is how does a device find its network details? Well, you know, it's remarkably like taking your laptop out of the bag in a hotel and hooking up to the wireless. You use the same thing, DHCP. So in the full stack document, we say, use DHCP. Use DHCP on the media networks, use DHCP on the management network if you're connected to it. Because there's no good reason not to. DHCP works. We've got 30 years probably of field experience using DHCP. Did I mention DHCP works? It's, you know, compared to having spreadsheets full of IP addresses that you type in here and you type in there and every mistake takes 6 hours to find, DHCP works. It's well known. It works at scale. When your town has a power outage and then everything comes back all at once, every cable modem in the entire town comes up and does DHCP simultaneously. And you know something? The world doesn't end. It works. There's some design involved in making it work, but that design's been done. That's been done by other industries, and all we have to do is use it. So media nodes shall by default use DHCP. Next question. This one's more complicated. So in broadcast, and this is just a tradition we have, if you have a device sitting there in the rack and you think it's misbehaving, what does any operator do? They walk over and they go click, click on the switch on front of it. That's like before they even call engineering. They just walk over and do that, right? Well, that's because we have a behavior built into broadcast equipment for years that says you come back up with whatever settings you were last running with. And that's served us well, and that still serves us well, and we're still going to keep doing that. The trouble with that in these environments is that you have to be able to differentiate as a device between I just got reset in the network I was in before, I'm going to come up and do everything I was just doing, versus, oh, I'm a rental camera and I just came back from some other shoot and somebody plugged me in this studio. Those are very different cases, but to the device, it has no way of knowing which one just happened, right? It doesn't know that it's waking up in a new environment or it's waking up in the environment it was in 10 seconds ago. So wouldn't it be great if it had a way to do that? Well, so we made one. We put a system GUID in a well-known place in the network. So when you wake up, in addition to finding the IS-04 registry, you find this other structure that's got this system ID. So you can tell, hey, this is the same system I was in before, so I can just come up and go. Or, hey, this is a different system than the one I was in before, so I'm going to mute my transmitters, and I'm going to disconnect my receivers, and I'm going to wait for someone to tell me what I'm supposed to do. And this is a really important behavior because if you just otherwise take a rental camera and you plug it in and it comes up and it starts blasting out a bunch of multicast streams, those could have address conflicts with other signals in your air chain that you care a lot about. So this is a simple solution to a hard problem. That's the best kind, right? It's better than having hard solutions to easy problems, which we seem to specialize in. So that's a behavior that's in the full stack spec. The third one that's interesting is finding the prevailing PTP parameters. How do you know what PTP domain you're in? Well, someone's got to tell you. So in that same structure that says what the system GUID is, another thing in there is what's the PTP domain we're all using? Because devices aren't born knowing that. They have to get told. Similarly, we actually put the announce timeout in there because if you have two interfaces to two media networks, each of which has PTP, the announce interval is a helpful part of the decision process to figure out which one you're listening to the PTP on. The slide says announce interval, but Kojima, who's on his second try with this talk now, pointed out last week that the announce interval actually you do find out from the announce messages. It's only the announce timeout that you need to get told. But you need to get told it. It's not something you're born knowing. So we defined a simple way to get that information distributed to everybody. IS-04, the same thing. When you wake up and you need to find the registry, IS-04, as it was written, says you could do MDNS, you could do DNS service discovery. Well, MDNS has a lot of drawbacks for using in systems at scale. Most network architectures want to do layer 3 routing of the multicasts. Many of the switch architectures actually have their policing and other features sort of tied up with the layer 3 features of the switch. And so it's important to be able to use ports as layer 3 ports in the switches, but that tends to stop protocols like MDNS from working. So DNS service discovery is thankfully a unicast mechanism to do it. How do you know where the DNS server is? DHCP told you where it was. There you go. You get a bonus. If you use DHCP, you get the DNS criteria. You can find the DNS server. It tells you where the registry is. See, this all fits together if you just do it all. So that's the trick for IS-04 is you use DNS service discovery to find the registry. Ooh, that's loud. Okay. So there you go. Now, this little bit of global information like the PTP domain, the announce interval, the system GUID, there's a couple other things as well. What we did is we defined a new structure that will be called something like XNMA system globals. And it lives in the network. It has a name that you look up in DNS service discovery to find it. You could put it on the same computer that's running the registry, but you don't have to. It's got its own name pointer. And so it tells you the handful of things you'd like to know. There's one of the things in there is the registry heartbeat. How often does the registry expect you to re-register? Because again, as the system gets larger, you may decide that you want to have a lower number for that, but we'll let the Sony guys talk about that in a minute. I don't know if you talk about that or not. But, the domain number, other stuff. So it's a nice little structure, but it defines a bunch of global parameters, and it's a place we can hang more if we realize we need them. So the fifth behavior is the hardest one. And this is really the nutshell of the system. Right now, every 2110 system that I've seen built, I've seen a couple, you wind up with a big spreadsheet of every multicast group and who's transmitting what and why, and you go hand provision all of them. And most vendors have some automated tool to help with that, but it's just making something tedious a little less tedious. So ideally, there'd be some automated protocol-based way to do this. Now, there is an RFC called MADCAP. Who comes up with these acronyms? I don't know. It stands for something logical. And I think every one of us involved in this has at some point read the MADCAP RFC and said, hey, this sounds great, this sounds okay, this sounds, oh, I wish this worked differently. It wasn't written for us, it was written for some other purpose. I'm sure it worked for whatever it was written for, but it doesn't sort of work well for this. So IS-05, the connection management API, normally we think of it as managing connections to receivers, but it actually does define as well how you can write to a sender and tell a sender what addresses to use. But most senders right now don't support that because it's tedious. So the full stack document says, senders shall support that. Boy, those were just easy words to type. It'll take work, but it's really, we have to get hold of this aspect of the complexity of systems. And so it's just, as a community of vendors, we have to just get over that we're going to have to support that, because if we don't support that, we'll have to come up with some other thing that's just as difficult. So let's just support the one that's written down already. Another little note there is that media nodes have to support the entire range of addresses. We've seen different hardware from different vendors that has different weird constraints of, oh, I only work in 239.37.5 domain. Well, that's nice, but that's not, if you're trying to build a system that has things from multiple vendors, you pretty quickly get incompatible weird constraints. So we put in the document that no, as a media node, you have to support whatever address I tell you to use. Now, that doesn't mean that the network has to support that. The network can have all the weird constraints you want. In fact, many customers have multicast restrictions because they have to work around that their corporation already has an address plan, and that some multicast groups are used for certain purposes elsewhere in the corporation, and that you can't use them in your broadcast plant. That's fine. But what we've done in the document is to say, okay, the devices, the media nodes, cannot insert extra weird requirements. They have to take whatever addresses that they need to. Okay, so where are we at as I wind into my Q&A period? So there was a drafting group, story of my life. There's a drafting group that's been tasked to put this document together. There's a very carefully worded sentence there that we're using the AMWA IPR guidelines with representation from many of the member organizations, including a reasonable number of broadcasters and a reasonable number of vendors and a reasonable number of other people. It's kind of the right cast of characters. I think every major vendor is represented in there. Every major, the EBU and a number of other major customers are represented in there. And it was really, the purpose of that was to get a document on the table that was 98% correct. So there is a document. We will wind up holding some kind of interop events, workshops, whatever you want to call them, probably in the spring, probably in Texas, because Texas is lovely in the springtime. It's either raining or hot. And those events serve a great purpose, right? Because you need to establish that everyone actually read the document the same way. I've learned that no matter what it says, people can interpret it different ways. But on the whole, if as a community of vendors we don't come up with common approaches to these system problems, it's just going to be really hard to build large systems. Technology alone doesn't do it. It also, you have to define these simple behaviors of products and expectation setting in regard to how our address is set and how things work. One of the biggest comments that people asked me to put in the document that I didn't quite know how to say correctly is, devices must implement the standards they implement correctly. And that sounds obvious, but it's still true, right? You have to actually, if you say, hey, I implement PTP, well, that means you implement one-step and two-step, because they're both part of PTP. If you implement 2110, but you only support, one funny subset of the features, well, that's going to be pretty limiting somehow. So that's the thing that no matter how many ways you say that, it doesn't matter if the document says that, because it's always implied that if you're building a device that implements these technologies, please take time to read, understand, and follow all of the normative sections of the document. So with that, I will open it up to questions and comments and whatever else you got. Oh, here's the first one from my friend, Mr. Kovlik.
It's nice and clean. It sounds like it's one page, John, but I can't believe it is.
It's less than 20, but I haven't looked. It's 13, 14 pages. No, it's not real long.
Only 5 points? I mean, I think you brought 5 or 6, right? Is that it?
5 points?
Well, you mentioned 5 specific.
Oh, there's 5 behaviors.
5 behaviors, sorry.
Yeah,
So
because
that's
otherwise
it.
the talk wouldn't fit in half an hour.
Oh, but are there 5 behaviors in the document?
Maybe. I mean, there's some of them have sub-behaviors. It's all
Oh,
how
okay.
you count. I don't call them out exactly this way in the document. It's organized a little bit differently than the slides.
Okay, thanks.
Hi, John. Paul Stuckley from Applied Electronics. Great paper as always. You referred to IS-04 and 5 as a standard under the heading of standards.
Did I? Well, there's specifications.
Okay, I can't tell you how many times John Luck scolded me for that on the board. But if that's the case, is there any movement to make them standards?
What would be improved by doing so?
Why isn't 2110 a specification then?
Because it was written in SMPTE. In SMPTE, we produce standards, and we produce them in a standards process. And it has, you know, the standards process creates documents that have a, you know, or maybe harder to create, sometimes not, but they have a fairly long life cycle. So I think the 2110 data formats will have a very long life cycle. Things like the AMWA specifications, they tend to be software APIs where you could reasonably expect that IS-04, while the 1.2 version is stable, there'll be a 1.3 version at some point because we'll add a feature, we'll add some other thing, and these specifications, because they're versioned, it's very reasonable to build a system that, you know, uses IS-04 1.2 to most of the devices in a fielded plant, but speaks 1.3 to the couple of devices that have the new feature you want. So I think it's a difference of, you know, what you call it and how they're created and so forth. But I don't know of any plan or grand scheme that says, oh, well, you know, these things are done except we need to start over in a different hat to call them a different document class.
Okay, thanks.
So pretty good presentation, thanks. Now thank you. So in the nice pyramid what we have, the fundamental layer on the bottom is about security.
Yes.
So what are we doing? Because if the fundamental bottom layer breaks, then anything else is not working.
So
what's the strategy?
So there is a task force working on a common security approach across all of these HTTP RESTful APIs. It's actually led by Mr. Edwards here, or involving anyway. I don't know if you're running that one, but they're close. They can be secured using basically the same tools that your bank uses. So if you trust it with your money, maybe you can trust it with television. That work is coming along. There's a bit of finishing left to do. So it's sort of a race of, you know, will we conclude the full stack document and leave some exercises to be done in a subsequent revision? Or do we, you know, delay finishing the first rev of the full stack document, waiting for the security document, waiting for maybe the channel mapping document, maybe waiting for the event and tally, maybe, you know, we cannot stop all of the trains to fix one of the tracks.
Got it, got it.
But we have to have an organized approach. No one, you know, we have to make, you know, likely the full stack document, there'll be a second revision of it that adds some more things.
So how does manufacturers feel on security-oriented documents? I could imagine they are quite nervous, huh?
No, I think the challenge with security of RESTful web APIs, because that's a much narrower topic than the problem of security in general. The problem of security for RESTful web APIs is actually a problem of making choices. It's not that there's no way to do it, it's that there's a great variety of ways to do it. And so I'm really thankful to the work that's going on in that group, because they've done the hard part of picking that which cipher are we using, which key passing method are we using, which token scheme are we using, how are the roles associated with the tokens. Those are all choices. And so that's the hard part that that group is doing, is picking the choices for all that. But I'm quite confident in the technologies themselves being secure, because they're not new inventions. They're all in common use in other industries securing money.
Okay, thanks.
At least I trust they are. Is that the case? Okay. Mr. Rosen.
You're a hardworking man. Hi, Andy Rosen, DSR, doing software right. And yes, 2071 and AES-70 really are standards. And as of last week, ODA is coming. So I don't see how full stack 1.1, 1.2, 1.3 is ever going to get supported by more than one or two audio manufacturers who expect things to be conformant and compliant for 10 years so the little blinking lights on the microphones keep working, which is why we're working so hard to rewrite 2071-3 so we receive your goodness and your stub, but also, even if we have to write it in UML, support the rich classes and architectures of AES-70, which can be adapted. So when ODA gets approved as a new project, A, please consider joining as a proponent, and B, please, there already are conformance and compliance tools coming from the Open Control Architecture Alliance. Maybe we should come to your plug fests and prove that we don't interfere with each other, please? Make audio manufacturers happy so they can declare new features and little blinking lights and things?
Okay, I'm not the zookeeper of this zoo, but I understand the request.
Thank you. I mean, again, AES formally sent X238 as a call for contributions, and I'm supposed to harmonize these things, so I'm responding.
Okay.
Okay.
It's Jeff Berryman has actually been doing a fantastic job with
Yes.
from inside AMWA and AIMS of advocating for AES-70, and he's not alone in it, and there are a number of other proponents also bringing this up right now. So yes, that is an active conversation.
Yes. And I am at Jeff Berryman's mercy. I'm learning UML and I'm trying to comply. So we should all harmonize.
Yes.
Well, that sounds like a good conversation for tonight at Spooktacular.
It's certainly spooky. Yes.
Thank you for watching. If you enjoyed this video, please tap the like button and also subscribe to our channel to receive notifications when we add new content. For more information about us, please visit SMPTE.org. We'll see you next time.